So what is the sine of the sine inverse of 1 over the square root of 5? So we start with this inside. Remember, sine inverse means we're plugging in a number, and the thing that's coming out, the answer, is an angle. We'll call that angle theta. Now, what quadrant is this angle going to be in? Since we're plugging into a sine function, a sine inverse function, this angle has to be in either quadrant 1 or quadrant 4. And since the sine is a positive number, positive 1/5, 1 over square root of 5, this is in quadrant 1. So here's our angle theta. And what do we know about our angle theta? Well, we know that the sine of that angle is 1 over square root of 5 because that's what we plugged into the sine inverse. So we can use SOHCAHTOA, opposite over hypotenuse. Here's my opposite. So this will be a 1. And this will be a square root of 5. We'll finish this off by filling in the rest of the numbers using the Pythagorean theorem. 1 squared plus side b squared is equal to square root of 5 squared. Remember, you must do leg squared plus leg squared equals hypotenuse squared. So 1 plus b squared is equal to 5. B squared is 4. So b is going to be 2. And then we just double check, do we need any negative signs? Since all of these are in the first quadrant, we don't. Now I want to know, what is the sine of that sine inverse? So that's like saying, what is the sine of theta? So opposite over hypotenuse. So in this case, sine inverse cancels with sine. But you have to be careful, it's not always that case. Let's try the next problem. Cotangent of cosine inverse. Now, cotangent is not the reciprocal or the opposite. Cotangent is not the opposite of cosine inverse. So we really have to be a little more careful with this one. Cosine inverse, we start with asking, what is the thing on the inside here? Well, remember, if we plug a number into cosine inverse, the answer that comes out is an angle. So we're going to let the angle theta equal cosine inverse of negative 8/9. Now we need to figure out what quadrant we're in. Since this is a cosine inverse, this answer that comes out, theta, has to either land in quadrant 1 or quadrant 2. And since the number that we plugged into cosine inverse is negative, we're going to land in quadrant 2. So our angle theta has a reference triangle in quadrant 2. And we know, since this is a cosine inverse of negative 8/9, the cosine of this angle answer will be negative 8/9. So adjacent over hypotenuse is cosine. So we can label our adjacent and our hypotenuse side. We're going to use the Pythagorean theorem. So leg squared plus leg squared equals the hypotenuse squared. It always has to put the hypotenuse as your c. So a squared plus 64 equals 81. So a squared is 81 minus 64. 17. So a is the square root of 17. So we can put that on this side of the triangle. Now, remember, if we're not in quadrant 1, we have to watch our pluses and minuses. Since we have to move left on the x-axis, this 8 will be a negative 8. But since we are going up on the y-axis, the square root of 17 will be a positive. Now that we have our triangle labeled and the signs are all correct, now we want to ask ourselves, what is this answer? Well, we wanted the cotangent of cosine inverse of negative 8/9. Those don't cancel. But we said cosine inverse of negative 8/9 is going to be this angle theta that we just put into that quadrant. So what is the cotangent of theta? Well, tangent TOA is square root of 17 over negative 8. So cotangent will be the upside down of that, or 8 over the square root of 17. We can actually start leaving it like this in AP Calculus. You don't have to necessarily rationalize everything anymore. In calculus, we don't mess around with that anymore. But if you needed to rationalize it, remember, you're just going to bring that square root to the top and take the bottom out of the square root and make sure nothing reduces. So either of these answers is appropriate in